In this video, I will cover solving quadratic equations using the quadratic formula. These examples will automatically include imaginary numbers and using the discriminant to find the number of real and imaginary solutions and simplifying square roots. So when we talk about solving a quadratic equation using the quadratic formula, we need to make sure that our quadratic equation is in the form ax squared plus bx plus c equals 0. If any of your equations don't equal 0, then you'll need to set them equal to 0 first. Then you can apply the quadratic formula to solve for x. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's look at our first example. X squared minus 10x plus 25 equals 0. Now we can see that this is written in standard form, which is ax squared plus bx plus c equals 0. So we don't need to set it equal to 0 because it already is. If there was anything over here, we would want to make sure that we subtract and add everything and combine all like terms to set it equal to 0. We can see that our x squared term is first, our x term is second, and our constant is third. So then we can identify a, which is a coefficient of x squared. We can identify b, which is a coefficient of x, and our constant c. So let's do that now. A is equal to 1. That is a coefficient of x squared. There's an understood 1 there. B is equal to negative 10, and c is equal to 25. If you will write out a, b, and c, it just makes it easier to plug them into this formula here. So we're going to say x equals, because that's what we're solving this equation for, is x. So x equals negative b. So since we have negative 10, this will turn it into positive 10. Plus or minus the square root of b squared. So we'll square this. Minus 4, and then we'll plug in our a in here, we'll plug in our c here, and again we'll plug in our a here. So we have x equals positive 10, since minus a negative is a positive. And I really like to go ahead and square b here, because then I don't have to deal with the negative. Especially if you're using a calculator, you definitely need to be very careful about the negative and make sure that you square the negative. So this number here is always a positive number no matter what. So if you're using a calculator, make sure you use those parentheses. Minus 4 times a, which in this case is 1, times c, which in this case is 25, all over 2 times a, which is 2 times 1 in this case. So now we need to simplify. Now your calculator will follow order of operations. So if you go ahead and just plug in all this at one time, it will multiply first and then it will subtract. If you're doing it by hand, then you want to make sure that you multiply 4 times 1 times 25 before you subtract. So we're going to do 4 times 1 times 25 is 100, all over 2 times 1, which is 2. Now we can see that here we have 100 minus 100, so this is going to turn into 0. So we're going to write 10 plus or minus the square root of 0 over 2. Now, the square root of 0 is 0. 0 times 0 equals 0. So what this turns into is just 10, and I'm just going to write this all out for now, just to really explain this. So the square root of 0 is 0. So 10 plus 0, or 10 minus 0, makes absolutely no effect on 10. So we can just get rid of this plus or minus 0, because it has no effect. So this is equal to 10 over 2, which we must always simplify whenever we can, So our final answer for x is 5. So this is the only solution that this quadratic equation has. If we plugged in 5 for x, we would have 25 squared minus 10 times 5 plus 25. So that would equal 0. Whenever you're solving an equation, you should always plug your answer back in to check it to make sure that you did it correctly. So in this case, we have one real solution. Since x equals 5 is our only solution, and 5 is a real number, we have one real solution. Now, sometimes you'll be asked to just determine how many and what type of solutions a quadratic equation has. And you don't actually have to solve it, you just have to say how many and what type. So the only thing that you have to actually find in that case is this part that's under the square root. This is what determines how many and what type of solutions you have. This b squared minus 4ac part of the quadratic formula, this is known as the discriminant. So you can see in this case, our discriminant, the b squared minus 4ac part, equaled 0. And then we ended up with one real solution. Because this is always going to be a real number here, and this divided by this will be one solution since we're not plussing and minusing something to this number. We're only going to get one solution, and it's going to be a real solution. We'll keep talking about this with every example that we do. So we can make the note here, when b squared minus 4ac equals 0, there is one real solution. Let's look at another example. 2x squared minus 5x equals 3. We can see that this is not in standard form, which is ax squared plus bx plus c equals 0. So we need to subtract 3 on both sides. So we have 2x squared minus 5x minus 3 equals 0. Now we're ready to identify a, b, and c. A is our coefficient of x squared, 2. B is our coefficient of x, -5. And c is our constant, -3. So now we're ready for the quadratic formula, which I'll write down again here. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we can plug in our numbers. So again, we do have that b is a negative number. So when we do -b here, that will change this number to a +5 here. Then we have b squared. So 5 squared is 25. Minus 4 times a, which is 2, times c, which is -3, all over 2a, which is 2 times 2. Now, I do recommend going ahead and changing the sign on b and squaring b here. But here you need to be very careful to not try to do too much of this in your head, because you really need to watch these negatives here. Since you have minus a negative, you're going to end up adding these two numbers, and that's where you do need to be very careful. So we have x equals 5 plus or minus the square root of 25 plus 4 times 2 times 3. Make sure you multiply these first. So you can multiply any of these three numbers in any order, but just don't subtract from 25. Okay, so we can do 4 times 2 is 8, times 3 is 24. So we have 24 all over 2 times 2, which is 4. So we'll have 5 plus or minus the square root. 25 plus 24 is 49 over 4. Now 49 is a perfect square, so we can take the square root of 49, which is 7. So we have x equals 5 plus or minus 7 over 4. Now this will give us two solutions. We're going to have 5 plus 7 over 4, and we're going to have 5 minus 7 over 4. And we do need to simplify both of these because we can combine like terms, so we have to do that. 5 plus 7 is 12 over 4. We have to simplify to get 3. 5 minus 7 is negative 2 over 4. We have to simplify to negative 1/2. So in this case, we have two real solutions. They're not imaginary, so they're real. They're real numbers. Now, let's talk about the discriminant. Remember, the discriminant is just this b squared minus 4ac part, which ended up being 49. So 49 is not 0 like we had in the last example. So this actually did give us two solutions, this number being greater than 0. Because we could do 5 plus this number divided by 4 and 5 minus this number divided by 4, giving us two real solutions. So we can write when b squared minus 4ac is greater than 0, then we have two real solutions. For our third example, we have negative x squared plus 1 equals negative 8x. We can see that this is not in our standard form, so we're going to write it in standard form. We want our x squared term first. We'll add 8x to both sides, and then we have our constant set equal to 0. Now we're ready to identify a, b, and c for our quadratic formula. A is equal to negative 1, b is equal to positive 8, and c is equal to positive 1. Go ahead and write down the quadratic formula from memory and then unpause the video. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we will have x equals negative b, so negative 8 plus or minus the square root. All right, we'll square 8, so that's 64 minus 4 times a, in this case is negative 1, times c is 1, all over 2 times a, 2 times negative 1. Now we'll simplify. So what we want to do is make sure we're watching these signs here. So we have minus and negative, so this is actually going to turn into adding. So we're going to end up adding 4. 4 times 1 times 1. 2 times negative 1 is negative 2. So we have negative 8 plus or minus the square root of 68 over negative 2. Now 68 is not a perfect square, so we need to simplify it as much as we can. What perfect square goes into 68? So you know it's an even number, so you know that you could divide it by 2 and get 34. If that helps you, think about smaller numbers. Now, you can always also make a list of perfect squares to make it easier. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. So which of these perfect squares is 68 divisible by? 4. So you could always do this on the side as well if you needed a little more room. So you can look at the square root of 68. This is equal to the square root of 4 times the square root of 17. Because we know that 68 divided by 2 is 34. Divided by 2 again is 17. So divided by 4 is 17. Now the square root of 4 is 2. And the square root of 17 we cannot simplify, so we leave that as is. So we are going to substitute 2 square root of 17 for the square root of 68. Remember, we must simplify whenever we can. So this is going to equal negative 8 plus or minus 2 times the square root of 17 all over negative 2. Now we've simplified the square root as much as possible, but we haven't simplified this whole entire thing as much as possible, because now we can divide negative 8 by negative 2 and 2 by negative 2. So make sure that you never divide the number under the radical with what's down here, because this is the square root of 17 is not 17. But this 2 we can divide by negative 2. You could split it up if that helps you. You could do negative 8 over negative 2 plus or minus 2 square root of 17 over negative 2. So, or you could just do it all in one step. Negative 8 divided by negative 2 is 4. Plus or minus 2 divided by negative 2 is negative 1. But because we have this plus or minus here anyway, the negative really does not matter. If you're adding a negative, that would be like subtracting. And if you're subtracting a negative, that would be like adding. So you're really kind of just creating more work for yourself. So we leave the negative off at this point because we're going to add and subtract anyway. So we're going to just do the square root of 17. Since it's 1 times the square root of 17, we don't write the 1 down. It's understood. So this is our final answer. Now you can see that we still have 2 real solutions here. Because this is not imaginary. There's no I here. It's not negative under the square root. So the square root of 17 is still a real number. If you put it in your calculator, then you could see that it still gives you a real number. Now most teachers are going to want you to leave it in this exact form and not decimal answers. The only time that you really want to turn this into a decimal answer is if you have a word problem, and then it just makes more sense to have a number instead of this exact answer. But we can see that we still have 2 real solutions because our discriminant, which is 68, if we just did this equation here with b squared minus 4ac, we would have gotten 68. So that number is still greater than 0, which tells us that we have 2 real solutions. Let's look at another example. 10x equals negative 7 minus x squared. So we know we need to put it in standard form first. So we're going to add x squared to both sides, then we want our x term, and then we want our constant. So we're going to add 7 to both sides to set it equal to 0. Then a equals 1, b equals 10, and c equals 7. So when we're solving for x, we do negative b plus or minus the square root of b squared minus 4ac all over 2 times a. We simplify. Four times 7 is 28, so we're going to do 100 minus 28, which is 72. It might be helpful to simplify the square root of 72 by thinking about our perfect squares again. So which one of these perfect squares goes into 72? Again, you see that 72 is an even number, so you could divide by 2 to just see what you get and see what smaller number you get. And if you divide 72 by 2, then you get 36. Now you might have thought 8 times 9, which is also correct. And you know the square root of 9 is 3. But the square root of 8 has a perfect square inside of it as well, the square root of 4. So you're just creating more work for yourself. You really need to look for the biggest perfect square inside a number. So in this case, to simplify the square root of 72, we can say, okay, well that's the square root of 36 times the square root of 2. Since 36 times 2 is 72. And the square root of 36 is 6, and then we're just left with the square root of 2. So we'll make that substitution in for the square root of 72. Make sure that you simplify your root before you do any dividing with the 2 on the bottom. So we're going to have negative 10 plus or minus 6 square root of 2 over 2. Now again, we have these two numbers that are divisible by this number, so we must simplify. We're going to do negative 10 divided by 2 and 6 divided by 2. Again, we cannot do anything with this 2 that's under the radical, because this is not 2, this is the square root of 2. So, negative 10 divided by 2 is negative 5, plus or minus 6 divided by 2 is 3 times the square root of 2. And that is our final answer. So you see that we still have two real solutions. We have negative 5 plus 3 times the square root of 2, and we have negative 5 minus 3 square root of 2. So that would give us two different numbers, two different real solutions. If we put it in the calculator, we would get two different decimal answers. Of course, we can see that our discriminant was 72, which is greater than 0, so we would know that that would give us two real solutions. Let's do another example. After this example, my next two examples will have imaginary solutions. So in this case, we have it in standard form, so we can see that A is 2, B is negative 7, and C is negative 13 over 4. So for our solution, we're going to have negative B, so that'll be positive 7, plus or minus the square root of B squared. Negative 7 squared is 49, minus 4 times A times C. All over 2a, 2 times 2. So let's simplify. So in this case, we have this 4 here and this 4 in the denominator here, so we could just divide those out. Or you could always do 4 times 2 is 8 times negative 13 in your calculator and then divide by 4. But of course it would be much easier, and we could do it in our head, if we just went ahead and said, okay, 4 divided by 4 is 1. So then all we have to do is 2 times negative 13, which is negative 26. Now since we have a minus here and a negative here, this will be minus a negative, we'll be adding. So we'll be adding 26. So then let's add 49 and 26 to give us 75. Now we need to simplify the square root of 75. So go ahead and pause the video and simplify the square root of 75. The square root of 75 is the square root of 25 times the square root of 3. Square root of 25 is 5 times the square root of 3. So we'll make that substitution in for the square root of 75. So we'll have 7 plus or minus 5 times the square root of 3 over 4. Now in this case, we're going to leave our answer like this as this fraction because we cannot divide 7 by 4 evenly, and we can't divide 5 by 4 evenly. So we're just going to leave it like this. We can see that we have two real solutions still, since we have 7 plus or plus 5 squared root of 3 over 4, and we have 7 minus 5 squared root of 3 over 4. Now let's look at two examples that will have imaginary solutions. This is in standard form, so we can identify A is 3, B is -9, and C is 9, and plug it into our quadratic formula. So we'll have x equals 9 plus or minus the square root. -9 squared is 81 minus 4 times A times C all over 2 times A. So we'll multiply. So here we have 4 times 3 times 9. So we have 12 times 9, which is 108. And we are subtracting 108 here since we have minus and we don't have any negatives here. Now the other way we could minus is if we had two negatives here. Okay, but here we just have minus 108. So now 81 minus 108 is -27. Now we're going to simplify the square root just like we do positive square roots. So how would you simplify the square root of 27? This is the square root of 9 times the square root of 3. The square root of 9 is 3. So the square root of 27 is equal to 3 times the square root of 3. Now remember that the square root of -1 is I. That's our imaginary unit I, square root of -1. So what we can do is whenever you have the square root of a negative number, it's the square root of -1 times that number. So the square root of -1 is I. You always write the square root of -1 as I. And then we simplify the square root of 27 as 3 times the square root of 3. Now, in a standard form, the way we write it is we'll write the number outside the radical, and then we'll write our I, and then we'll write our radical. It's just a sure way to show what's underneath the radical and what's not. So you can write this in a different order because they're all just multiplied together, so the order really doesn't matter. But just be extremely clear about what's under the square root and what's not. And this is really the standard form that you would see it on all standardized tests and if you're checking your answers in the back of a book. So this format is really best to get used to. So we can make this substitution, 3i squared root of 3 for the square root of -27. And now you can see that we're not quite done simplifying. We still have common factors between these numbers up here and this number in the denominator, so we have to simplify. So again, you can split it up if that makes it easier for you. You can write 9 over 6 plus or minus 3i over 6 times the square root of 3, right? So that way you're not dividing things and then forgetting to divide. Like if you're dividing the 9 by 6, but you still need to make sure that you divide the 3 by 6 as well. So 3 goes into 9 3 times and into 6 2 times. So this will simplify to 3 over 2 plus or minus. 3 goes into 6 2 times, so this will simplify to 1/2. So we don't have to write the 1 since we have the I square root of 3 over 2. And this is our final answer, or you might see it written like this instead. All is 1 fraction over our common denominator. This is a more common way to write it. Now we can see that we have 2 imaginary solutions. Because of this I here. Anytime we have an I, is an imaginary solution. And we have 2 because we have 3 plus I squared of 3 over 2, and we have 3 minus I squared of 3 over 2. Now we could have seen that by our discriminant. Just b squared minus 4ac would have given us a number negative 27. So that is a negative discriminant. Your discriminant is less than 0, negative less than 0, and therefore you get 2 imaginary solutions, because anytime you have a negative under a square root, you're going to have an imaginary number. Let's look at another example. This is our last example. X squared minus 2x plus 9 equals 0. It's in standard form, so we can identify A as 1, B is negative 2, and C is 9. So for x, to solve for x, we'll do negative b, so that would be positive 2, plus or minus b squared would be 4 minus 4 times a times c, all over 2a. So we'll simplify. 2 times 1 is 2. 4 times 9 is 36, so we have 4 minus 36, which is the square root of negative 32. So go ahead and pause the video and simplify this, and then unpause the video and check your answer. So when we want to simplify the square root of 32, I'm going to ignore the negative for now just because it's just I. I know the largest perfect square that goes into 32 is 16. So the square root of 16 times the square root of 2. Square root of 16 is 4. So I'm going to make that substitution here and make 4i square root of 2, since it's a negative 32, and then this is all over 2. Now this can simplify, and so I can rewrite it as 2 over 2 plus or minus 4i square root of 2 over 2. My two different terms across the plus or minus sign. 2 divided by 2 is 1, plus or minus 4 divided by 2 is 2, 2i square root of 2. This is my final answer. Now, it's very important that you do write this 1 here. 2 divided by 2 is 1. Now, we don't write the 1 if we have something else, because the 1 in front of it is understood. But if we have nothing else, it's very important that we write our 1. If you do 1 plus 2i squared root of 2, that would give you a totally different number than if you did 0 plus 2i squared root of 2. So you definitely have to have this 1 here. Now you can see that because we have our I, we have 2 imaginary solutions again, which we would have recognized by our negative discriminant, negative 32. I hope you've enjoyed this video. Please like, subscribe, and comment, and check out my other videos. If you're interested in learning more about imaginary numbers, I have another video on the imaginary unit to different exponents. Please check it out.